So hello and welcome to my presentation of autonomous repeatable vehicle. I'm Krishna and in today's presentation I'm going to talk about my car design, and along with that we'll also share the electrical equipments and controllers used in it. So before we start, there's some information about the task. The task was to enhance the model we designed for the 2021 iMac challenge with microcontrollers and ultrasonic sensor. The design vehicle has to travel straight in a forward direction with the action of the switch, and when the vehicle comes close to the wall, the sensor has to detect the wall and then the vehicle has to start moving in a backward direction. The maximum budget for the task was £100, and Arduino, ultrasonic sensor and MOSFET were some of the compulsory items installed on the vehicle. In motor, only a DC type motor were permitted to use, and instead of using glue, only mechanical fasteners were allowed to assemble the parts on the vehicle. So this right here is a description of my vehicle, which includes the information about the electrical equipments and controllers used. And in DC motor specification, you can see the RPM value and the torque value of the motor was quite high. So to reduce this value, I have used 3 10 to 50 teeth per gear and 1 12-teeth pinion gear, which gave me an overall gear ratio of 1:104. So now let's see the CAD model of my design. At the front, there is all the electrical equipments for the vehicle like Arduino, breadboard, battery holder and ultrasonic sensor. The sensor has been placed 40 mm, which is 4 cm away from the front in order to detect the wall accurately. And then at the back, there is car brackets, then gear brackets and hook bracket. All these brackets are fitted on the wooden plank, and then steel shaft has been assembled on the car brackets and are supported with the help of shaft collar and polythene bush. Then 60 mm diameter aluminum wheels has been assembled on the shafts, and the gearbox is there to reduce the RPM and the torque value which are produced by the motor. Then there is 20 mm hook brass to determine the distance traveled by the vehicle. And in mechanical fasteners, there is M3/6 slotted cheese head screw, M3 thin washers, and M3 hex thin nuts. So this right here is the 2D drawing of my vehicle with all different angle views. And in the next drawing, there is a small bill of material which has the information about the part name, part number and the quantity of the part used. Manufacturing process involved in my vehicle is 3D printing of the ultrasonic sensor holder, laser cutting of the wooden plank and all the brackets used in the vehicle, and cutting down of the 330 mm shafts to 220 mm and 50 mm shafts. Along with the 2D drawings, I have also made a separate bill of material which includes the description, manufacturing process and the cost of all different parts in the vehicle. After adding up the cost of all different parts, the final costing came out to be £67.20, including the cost of jumper wires which are going to be part of the electrical equipments. So this right here is the complete circuit connection for my vehicle. Here I have used 2 N channel and 2 P channel MOSFETs to control the motor in a clockwise and anti-clockwise direction. Then 2 1K ohm cool down resistors to let MOSFETs know what their task is, and 1 SPDT slide switch which controls the 5 volt power coming from the Arduino, and 1 ultrasonic sensor to detect the distance. And in ultrasonic sensor you can see there is 1 trick pin and echo pin. Trick pin is the one which shoots the sonar sound, and echo pin is the one which receives the sound coming from the object and then calculate the distance. And now I'll show you how you can control a DC motor with the help of MOSFET and ultrasonic sensor. So here I have written down few lines of codes, and in the first lines I have determined the pin numbers and pin mode, and in loop I have determined that when the distance is, if the distance is less than 4 cm, the motor will rotate in an anti-clockwise direction, and else, which means if the distance is more than 4 cm, the motor will rotate in a clockwise direction. So now let's see how it works. So when I start the simulation, right now the distance is less than 4 cm, so it is rotating in an anti-clockwise direction, and when I increase the distance, which is more than 4 cm, it is rotating in a clockwise direction. So now let's see the code which I have written to achieve the result section for the assignment. At first I have determined the pin numbers and pin mode, and in loop I have determined the code to make the ultrasonic sensor work. Trick pin is the one which will shoot the sonar sound, and echo pin is the one which will receive the sound coming from the object. Low means switch off and high means switch on. And then I have determined that if the distance is greater than 0 but less than or equal to 4, the motor will stop for 5 seconds and it will start rotating in an anti-clockwise direction for 10 seconds. And if the distance is greater than 4 but less than 15 cm, the motor will start rotating in a clockwise direction. Else, both the pins will be switched off and motor will stop completely when the distance becomes greater than 15 cm. So basically right now I have uploaded the final code to the Arduino, and right now the distance between the wall and the sensor is less than 15 cm. So now we're gonna see what happens to the motor when I turn on the switch. So when I turn on the switch, the motor starts rotating in a clockwise direction. And now we're going to see what happens when the ultrasonic sensor detects the wall, which is when the distance becomes less than or equal to 4 centimeter. So when it detects the wall, the motor stops for 5 seconds and now it will start rotating anti-clockwise direction for 10 seconds. And now after rotating anti-clockwise direction for 10 seconds, when the distance becomes greater than 15 centimeter, the motor completely stops. So yep, that's all by my side. Here are some of the references which are used for the assignment. Thank you so much for listening me and have a great day.